In this video, we are going to talk about section 2.5, transformations of functions. Here we're going to learn how to identify transformations of functions and apply them to either a given graph or one of the known common functions. So this video for this lecture will also be in two parts. For part 1, we're going to learn about what are the common functions, how to apply vertical and horizontal shifts, and reflections. So we have 5 equations and graphs that represent what we consider to be common functions. These are basic equations and shapes that you should know from memory. So the first one is f of x equals x squared. The graph of f of x equals x squared looks like this. We call this a parabola. It's a U-shaped graph that opens upward. It goes through the point negative 1, 1, 0, 0, and 1, 1. Our next common function is f of x equals the absolute value of x. This graph goes through the same 3 points as x squared, but instead of forming a U, it forms a V. So it goes through negative 1, 1, 0, 0, and 1, 1, but they are connected in a straight line V-shaped graph. Our third common function is f of x equals x cubed. This one goes through the point negative 1, negative 1, 0, 0, and 1, 1, and it forms this vertical S-curve. The next common function is f of x equals the square root of x. This one goes through the point 0, 0, and 1, 1, and it starts at the origin and then curves upward, but is what we would call concave down. So it's increasing but very slowly, as opposed to in x squared how it increases very quickly. So this is the shape for f of x equals square root of x. And the last one is f of x equals the cubed root of x. This one goes through the same 3 points as x cubed, goes through negative 1, negative 1, 0, 0, and 1, 1. But for the cubed root, it forms a horizontal S-curve that starts off to the left, curves through those 3 points, and then flattens off as it moves to the right. You should know the equations and shapes of these 5 functions and their graphs. We will see them frequently. All right, the next part of this section, or the main part, we're going to learn about how to apply transformations to either one of the 5 basic functions or some given graph. So our first set of transformations are what we call vertical shifts. So in other words, how to know if the graph we're given is going to move up or down. Y equals f of x plus c would represent the graph of whatever the graph of f of x looks like, shifted upward c units. So adding a constant behind the function will move it up on the coordinate plane. Similarly, y equals f of x minus c, so subtracting a number behind or outside of the function, will represent the graph of f of x, whatever that may look like, shifted downward c units. So when you add or subtract outside of the function with a constant, it moves the graph up or down. Horizontal shifts are identified by adding or subtracting a number inside the function. So y equals f of x plus c, so this time we're adding on the inside, will be the graph of f of x, the shape for the function f of x, shifted left c units. So we're going to move left or right when we're adding or subtracting inside, and it's backwards of what you might expect. Vertical shifts make sense. Adding moves up, subtracting moves down. Horizontal shifts are backwards. So adding on the inside is going to move to the left. Likewise, y equals f of x minus c, subtracting on the inside. We'll take the graph of f of x and shift it horizontally to the right c units. So you're just going to have to memorize that adding or subtracting on the inside is a horizontal shift, opposite direction of the sign. So we are going to use the next example to show how each of these work. So here's an example where they provide us a graph of f. So this would be a given graph, some random shape. Use the given graph of f to sketch first the function h of x equals f of x plus 2. And then secondly, they want us to graph g of x equals f of x plus 2 to show the difference between how adding outside versus inside is different. So for part A, if our graph needs to be the graph of f of x plus 2, it means I'm going to take what I know f looks like, that was given, and I'm going to move that graph up 2 places. So I'm going to start with each point and do the transformation. So if I start at this point and I take this x value at -3, y value of 0, and move it up 2, it would have started here and gone up 2 spots and landed right here. This point is at y value of -2, so if I shift it up 2, it should land right here at that spot on the x-axis, which I made a mistake here. This should be right here at x equals -2, y equals 0. I moved it up a little bit too far. So that should be here. This point, 0, should have gone up 2 to y equals 2, so it lands right here. This y value at 1 would have gone up 2 and landed at 3. And then the other y value was also at 1, so it went up 2 and also landed at 3. So this point should have been down here on the x-axis. So this should have come from here, touched down here, and then connected over to these 2 points and then across. Part B should be the graph g of x equals f of x plus 2. So this time we're adding on the inside. So that graph is going to move f of x left 2 places. So my original graph here would have started at the -3 right here and moved it left 2, landing it at -5. This corner right here at -2, -2 would have gone left 2 over here to -4. The other point at the origin goes left 2, lands at -2. The 1, 1 point goes left 2, lands right here. And then the other point here on the end was at 2, 1, and if it goes left 2, it would land right here on the y-axis. This next example is using one of our common functions, and it's applying both a horizontal shift and a vertical shift. So this one is f of x equals the absolute value of x minus 1, and then behind it -3. So this is a common function, one of our common shapes. It's the absolute value shape, so it's going to start off looking like this V. The transformations that we're going to apply inside of here, we have a -1, so if I'm subtracting on the inside, it's going to move it to the right 1. And then -3 on the outside will shift it down 3. So I just drew in this dotted V to show where we would be starting from, the absolute value of x common function. So these 3 points we're going to move. So this point is going to move to the right 1, down 3, and land right here. this point is going to go to the right 1 and down 3 and land right here. And then finally the last point will go to the right 1, down 3, and land right here. So notice the points still line up in a V shape. So we can draw the same shape through those 3 points. Next, we're going to go over how to apply reflections, or how to identify them and then apply them. Y equals negative f of x is the graph of f of x reflected across the x-axis. So it is a vertical reflection. Y equals f of negative x is the graph of f of x reflected across the y-axis. So it is a horizontal reflection. So let's use one of our common functions as our first example. G of x equals the square root of negative x. So the common function is the square root of x. So that would be this shape to start with. The transformation, since we have a negative inside of the square root, when the negative is on the inside, we're going to reflect that across the y-axis. So the reflection across the y-axis, or the horizontal reflection, would be our transformation. So the dotted curve is where we would be starting from, the basic shape of square root of x. And then if you reflect that across the y-axis, notice this point is on the y-axis, so reflecting it across the y-axis does not move it, so that point stays where it is. So this other point we have to flip across the y-axis and it would end up over here. So in other words, the x value of 1 now becomes x value of negative 1 when it moves across. So then we just connect our points and draw the same shape. The second example, we're going to use this given graph, just the graph provided for us as the graph of f. So use the given graph of f of x to graph g of x equals negative f of x. So this time the negative is outside the function. So to draw that graph, we're going to reflect f of x across the x-axis. In other words, it's a vertical reflection. So if I'm taking this point and moving it across the x-axis, it means the y value is changing sign. So at positive 1 here, this moves down here to a y value of negative 1, right there. This point, y value changes sign when I flip it over, so it comes down here to y value of negative 2, right here. Right here we have a y value of 1, reflects across the x-axis to a y value of negative 1, so it ends up here. So my new graph ends up being upside down, flipped across that x-axis. So we're going to stop there for part 1, and then I will do a second video for the second half of section 2.5 for part 2.